Hey there, it's Joseph from Roboflow. Today I'm going to do something a little bit different. The very first Roboflow Ask Me Anything, AMA for short. That means we've heard questions from the Roboflow community, users on in-app chat, writing us email, commenting on our YouTube videos, and so we're going to take a moment to answer your questions and actually provide you a central way to ask us questions for the next time. So I'm your host, Joseph from Roboflow. Let's dive right in. Okay, so I've prepared a series of questions that we hear a lot of things about. And today's session dives into things that we've just heard across the platform. But this is an opportunity for you to submit questions to us. I've put a link in the description. If you have a question about computer vision, the Roboflow platform, or anything in between, you can always go to bit.ly/roboflow-ama. Ask us a question. Do it. Okay, so the very first thing I want to say is, what is Roboflow? It's how you manage your computer vision data sets, eliminate common errors, convert between file formats, create new images from Augmentation, pre-process your images, collaborate with your teams, export to any format, and use the model library to train the highest quality models possible. Okay, so the very first question is actually from Joseph. And he wants to know, what is the coolest thing you have seen someone build on Roboflow? That is a great question, Joseph. Thank you for asking. I mean, the truth is we've seen people build thousands of different applications. Applications like, very commonly, maybe identifying if someone's wearing a mask or not, given response to COVID. And on a more serious note, we've seen users use chest scans of x-rays to identify if it contains the presence of COVID-19 or not. We've seen users build things like apps that classify different types of sushi on mobile phones. Or we've seen large businesses build applications that monitor anything from energy resources to on-the-ground aerial imagery, identifying HVAC units on the roofs of homes in New York City, all over the map. I've compiled a few lists of some of these things that we've seen people across the Roboflow platform use us to build. I mean, things like gas leak detection, identifying if something's a weed or a plant, measuring fish on the platform, hard hat detection for those that are in workspaces, airplane maintenance, looking at different pieces and parts, estimating damage from roofs, for insurance claims, or helping things in the self-driving car space. You name it. Computer vision can help your industry, and we're so excited at Roboflow to hear about what our users are telling us of how they're using computer vision. Okay, another question that we commonly get, is YOLO V5 better than YOLO V4? So this is a really common question, and like most things, honestly, it kind of depends. Now, on the COCO benchmark, I do want to note that YOLO V4 does outperform YOLO V5. So COCO is a data set that Microsoft put out in 2014 to help us identify the success of given detectors. We've seen another video, I'll link in the description, that explains the COCO data set in more detail. But in general, it's a benchmark for common objects in context of identifying the performance of computer vision models. Now, YOLO V4 does do better than YOLO V5 on the COCO benchmark, and that is still true today. Now, if YOLO V5 is better or worse depends a bit on your use case. I mean, the author of YOLO V5, Glenn Jocker, actually has put out and said that his goals with YOLO V5 are not just mean average precision, but also ease of use, exportability, training with lower, less performant resources, having a more fast training model, of course MAP as well, and market size, just the number of people that could use computer vision that may not have access to YOLO V4. So, I mean, one of those things that YOLO V5 does that YOLO V4 doesn't do is automatically adjust the size of the anchor boxes. So if you have objects that are often like weirdly shaped or something like this, YOLO V5 may be more performant on that specific data set. The truth is, in general, YOLO V4 is the cutting edge, bleeding edge performance, but you'll notice here that the performance difference isn't that great. And if you use YOLO V5, it's pretty good for establishing a benchmark of just how good is my data set? Can I even train a model for this given problem? And so the truth is that it's not really an either or decision. A lot of the times you should try both and see where it works better for your domain. Ultimately at Roboflow, our goal is to support you to build any model with the highest quality data. So whatever model you select is ultimately best for your problem, by all means, That's awesome. And we can't wait to see what sorts of things that you build. Okay, what is the difference between pre-processing and augmentation? This is a question I get all the time from users. So pre-processing is really preparing your images for modeling and inference. Things like resizing your images or maybe removing EXIF data or things like this. Whereas augmentation is deliberately altering your images to increase variability of your training set to improve model performance. Now, actually, you know what's funny is that one step or one model or image transformation in one context could be a pre-processing step, but in another context could be actually an augmentation step. For example, if I grayscale an image, that means remove the color channels and just make it be black and white and shades of gray in between from 0 to 255, that step, if I want that to apply to my training and at inference when I put my model into production, it would be a pre-processing step. That means make everything be grayscale. But if I wanted to augment my model to be color insensitive, then I might randomly change some of my images. I don't want color to not be a part of any of my images, but I want some of my images to be black and white, some of my images to be color. Then I might augment my training set and make some of them be black and white. Now, in general, the difference of these two is that pre-processing images applies to your training, validation, and inference set, whereas augmentation only applies to your training set. Why? Well, pre-processing is basically making your images ready for your model to be able to use them. And that model might expect, say, 416 by 416 sized images. Augmentation, on the other hand, is increasing dataset size and variability. As an example of this, I actually have a given dataset pulled up here, my chess dataset. It's just, this one's a smaller one, so it's just 20 images. And so I'm going to add, for example, some pre-processing and augmentation steps so we can see what I mean by things that apply to the pre-processed images in the training set versus the other sets. So for example, my images to start off, I'll notice, are about 22084 by 1529, so they're pretty rectangular in nature. So the first thing I'm going to do is just resize to 416, 416. I'm also going to auto-orient my images, which removes the EXIF data that causes images to be oriented oddly. Now the others, I'm going to add augmentation as well. So I'm going to say randomly make my images brighter and darker because maybe my inference conditions could be randomly brighter or darker rooms. I'm going to randomly add a little bit of blur. We'll say 0 to 0.75 pixels. I'm going to randomly, we'll say, flip my images as well, horizontally, and I'll also do vertically just because it'll be really obvious to see much more easily in our data set. And then the last one that I'll do is, let's say I will randomly rotate my images. And actually I saw here I have random rotate from 90 degrees. So randomly upside down, sideways, all these things. Okay, now I'm going to create 3 versions of each of these images, and I'll have approximately 60 after we're done. It depends on the random number that we get generated here. I'm going to call my version just example. And so I'm going to generate these 3 versions per image, and then I'm going to download my images so you can see locally what I mean by the images that are in the training set versus the validation set and how they're affected. So you'll notice that I get this downloaded zip file here, open that guy up, and inside this folder, I have train, valid, and test. So in my training set, I have, for example, this image. And this one, you know, it's square. So the pre-processing step here of resize to 416, 416 happened. It's also rotated, as you can see. Now, a few others, this one's made darker, it's upside down. This one's brighter, it's still right side up. This one's inverted horizontally, you can see because the words are backwards. Horizontally a little bit brighter, darker, etc., etc., etc. So you can see those images are augmented in the training set and randomly edited a little bit. Now in my validation set, my images are only resized and the EXIF data has been stripped. So you'll notice that the images were pre-processed but not augmented. And the same is true in my test set. These 2 images here in my test set have been randomly, have been resized to 416, 416, but not augmented. Why do we do that? Because we want our images in inference and validation to be ready for our model to run on them regardless of the size that they should be. Whereas in our training set, we need our images to be various different sizes and shapes and colors and so forth so that our model, when it's trained, sees a bunch of different examples. That's a really good question. We get that a lot. Okay, one last question, tabs or spaces? Come on, really? Tabs. This shouldn't even be a question. All right, so thanks so much for participating in the first Roboflow AMA. As I mentioned, I would welcome you to ask additional questions. Be sure to subscribe and like so you know when we put out new videos answering your questions for us. Thanks so much.